All right, so much of the work that we've done so far has just been setting up the question, but really there's still lots to do. We were able to set up a picture, get all of our known or unknowns down here. We haven't solved them all. We're only going to pick the ones we need to solve. And then we've picked our trig ratio. Of course, now we're at the stage, once we have the equation, we have to differentiate. To make it just a little bit easier, I'm going to take this 1,000 and bring it up top here. Just so there's no fractions. And now I'm going to differentiate. So this is something, that 1,000 is just a coefficient, so it'll stay there. Times tan. So what's the derivative of tan? Secant squared, that's right. So now we actually differentiate. So it's 1,000 secant squared theta equals, this is just s, oh sorry. Remember, I'm differentiating with respect to time in all these because it's rate of change. There's no t in this equation. There's a theta, so when I differentiate the theta with respect to time, I have to have d theta by dt. So this was the line that this is the stage where I'm differentiating. On the other side, I have s. What's the derivative of s? 1. And of course, I'm differentiating with respect to t, so I need a ds by dt. Now I know all the functions that I need to actually figure out. Good news is, since d theta by dt is the one I want, I've got it in my equation. What I have to figure out, though, is secant squared theta, which means I'm going to have to figure out the actual theta. And I'm going to have to figure out the ds by dt one, which is this one right here. So the ds by dt is going to be the easiest of them to figure out. So I'm going to do it right off to the side here. From the top of the question, it says s is 200 t squared. Right, that comes right from here. So that's s, which tells me the height, but I want to know the rate of change of the height, so I'm going to differentiate that. So taking the derivative of that is, well, what's 200t squared? What's the derivative of that? 400t. And remember, all of this is happening at a certain snapshot. At what point am I actually evaluating all this sort of stuff? At 5 seconds, that's right. So you see that right here at 5 seconds. So when I go back down to here, I don't want any old rate of change. I want the rate of change at 5 seconds. So I can go off and put in 400 times 5, which of course is 2,000, and this would be meters per second squared. So, at the very least, what I've done over there is I've figured out my ds by dt. It's increasing at a rate of 2,000 meters per second squared. Okay, so I can put that in as one of my unknowns, 2,000. My d theta by dt is the thing I'm trying to figure out, so it's going to stay the same. The 1,000 part is not going to be an issue. All that's left is trying to figure out this secant. So this is where all the work's going to be. Secant theta. Secant is the reciprocal of which trig function? Cosine. Okay? So I'm going to try and figure out the cosine in this scenario and then just flip it around. Okay? So I'm going to need a whole other space to do this. So I'm going to do it down here at the bottom so it gets out of the way. So my goal eventually is to, actually I'll do it over here. My goal is to do the cosine. Only because I need to flip it to get the secant. Okay. Cosine is which ratio in SOHCAHTOA? Adjacent over hypotenuse. Okay. In my scenario, if I look at my triangle, the adjacent side to cosine is d, and the hypotenuse side is x. So in our scenario, I need, the adjacent side is d, and the hypotenuse side is x. I wish it was h, but I wasn't allowed to use h. Okay. All right. Which of these sides can I figure out? Well, the d part I already have. It's 1,000, right? But I need the x part. And to get the x part, I'm going to have to do a bit of work. So I'm just going to redraw the picture down here, if that's okay, just so I don't have to keep scrolling up and down. So this is 1,000, this is x, and this is s. I need to figure out how long that side is at a certain spot, right? This is all at 5 seconds. X would be very different at 1 second. It would be very different at 20 seconds. Right? If it's at 20 seconds, X would be really long. If it's at 1 second, X would be pretty close to 1,000. But we have to do it at 5 seconds. So at 5 seconds, the one thing I do know is what S is. S is, what is it, 200 t squared, right? We know what the rate of change is. We don't know how high it is. Okay, and this we're just trying to find the length. I'm going to need to find the length of this side so that I can use Pythagorean theorem to get the length of x. So I'm using this to figure out the actual height. So at 5 seconds, that's 200 times 5 squared, which is 25. And so that's 5,000. So this side is actually 5,000 meters high. And now I can use Pythagoras to figure out what x is. It goes x squared, that's hypotenuse, equals 1,000 squared plus 5,000 squared. I'm going to save you a little bit of work and do this. 1,000 squared is, 10,000, I think? Times 5,000, or plus 5,000 squared is 26,000, or 26 million, excuse me. Okay? I'm actually going to save yourself a little bit of work here. Instead of figuring that out, which is going to be some nasty decimal, I'm going to do this. I'm going to say that this is the same as 26 times 1 million. Because I can take the square root of 1 million. And the square root of 1 million is 1,000. Okay? And again, instead of figuring out the actual square root of 26, which is going to be some weird number, I'm going to leave it like this, and you're going to see how nice this is going to work out. So all this work is done to the side just so I could figure out what x is. Why did I want x? Because x is the hypotenuse that I needed to get cosine. So I go back over here, and I now know that this is 1,000 root 26. And guess what? The 1,000s are going to disappear. And I get 1 over root 26. This is cos theta. Now, that's great. My math is getting nicer and nicer with every line. But when I look at my equation, I don't even have a cosine in there. Why was I figuring out cosine? Because I actually needed the secant. The secant is the reciprocal of this. So the math gets even easier. What's the reciprocal of 1 over root 26? Root 26. That's the thing that I actually want to plug into my formula. Oops. So this is secant squared. So secant is root 26, but it's squared. So it actually goes like that. So now I can hear your minds blowing already. The 1000 is fine. What's root 26 squared? 26 d theta over dt, and this is 2000. 26 times 1000 is 26,000. I'm going to then take this 26,000, divide it by over on the other side, and d theta by dt is actually 2 over 26, or 1 over 13. Now, sorry, what did you say? Degrees a second? Yeah, except we're not in degrees here. We're going to do it in radians. Okay, so it'll be rads per second. Okay? And therefore, the angle increases at 1 over 13 radians per second. Okay. So again, just like with all the other ones, I don't bother finding every side because look, it didn't turn out, well, I did have to find x so that I could figure out this stuff, but I didn't have to find dx by dt, so I didn't bother. And I didn't actually have to find theta, so I didn't bother. I'm only going to go off and find the ones that I need at that time. Fortunately, this one required a lot of work to get it. Okay, so that's the end of this video. We're going to do another one with another